This is video 2 for the Strategic Design Unit. In this one, we're going to begin by talking about a cost-benefit analysis. This is a tool to help you make decisions. So in a cost-benefit analysis, we have basically two parts that I want you to do. The first part is tasks, and the second part is the build. So a task, it's something that your robot needs to do. So I want you to make a list of everything your robot needs to do. Maybe it needs to lift itself off the ground. Maybe it needs to throw an object a certain distance. But you need to make a list of all the tasks that it needs to do. And I'm thinking 2 or 3 tasks at least. All right, next you need to do the benefit. So for each task, give it a rating between 1 and 100. And what this means, a rating of 100 is something that the robot must do. It must move. It must be able to turn, things like that. A rating of 1 is something that's not important. So that's the benefit. Then for each task, you're going to give it a second number, or a second rating. This time, 100 is a task that is really, really hard to do. And a task that is given a rating of 1 is easiest to do. Once each task has its 2 numbers, we then find the ratio of benefit to cost. So this gives us a number. And we can use this ratio to make decisions. The higher the ratio, the more optimal. The lower the ratio, the least optimal. So imagine if we have something that has a benefit of 100, so we must do it, and a cost of 1. It's easiest to do. Then that ratio equals 100. I mean, that's a very, very high ratio. That's the highest you can get. That's something you have to do. But if something has a benefit of 1 and a cost of 100, now that ratio is 0.01. So that's the lowest that you can have, 0.01. You're not going to do that because the cost-benefit analysis doesn't work out. It costs too much for the benefit. All right, so those are tasks. Now for builds. I want you to make a list of everything you need to build. So if you need to build some sort of launcher, if you need to build a drivetrain, if you need to build a lifter, everything you need to build. And give each build a number or a ranking between 1 and 100. So a 100 means that you must build it. Once again, a 1 means it's not important. Now we have our cost. Give each thing you need to build a second rank. where 100 is something that's hardest to build, and 1 is something that's easiest to build. Once again, we're going to find the ratio of benefit to cost. And we can use this ratio to make decisions on things we want to build. So if everyone in your group has an idea for, let's say, a drivetrain, you can make a cost-benefit ratio for every single person's drivetrain, and then the person who has the highest ratio, well, that gives us an idea for which drivetrain you need to build. So one of the most common errors that can take place in one of these assessments is underestimating the level of difficulty. So you guys should probably have a better idea, being robotics 2, you should have a better idea for what is easiest and hardest to do and to build. Alright, the engineering design process. It's broken up into 5 steps: observe, brainstorm, compare, make, and repeat. And this really goes with the design award. So first off, we have observe. And it's based off what you need to do to win the game. I believe that rubric I gave you called these challenges. Yeah, what are problems? What are the challenges? You want to understand the problem. Engineering is problem solving. So you need to understand, make a list of all the problems that you need to solve. You need to be able to define your problem. So understand the problem completely. If the problem is, lifting the robot up, you understand everything that goes into that. How are you going to grab the competition ring to pick up the robot, things like that. So you want to understand everything there is about the problem or about the challenges. Brainstorming. Create design ideas for the game obstacles. Do your research. Don't try to reinvent the wheel. Be able to explain what your design should do. The next step is to compare. So if everyone on your team is designing something similar, like if everyone's working on a drivetrain or if everyone's working on a lifting mechanism, get together with your team, compare notes, take a look at everyone's design, and then work with your team to choose the best design. Use your cost-benefit analyses to help you with this. Use good team working. Work well on team to make your decisions. The next step is to make. So this is where you build a prototype of the design. Don't try to build the entire robot at this stage. You don't want to prototype an entire robot, because if something isn't working, you don't want to have to disassemble an entire robot just to fix maybe one gear or something. Prototype just little parts of it, and then when it gets closer to the end, start putting the entire robot together. Test your prototype. Got a P up there. So when you test your prototype, try to make some sort of procedure for it to follow. Base your procedure off of what is needed for the game. Sometimes it's a good idea to build multiple prototypes. Just to kind of see what will work best. Finally, we have the most important step, and what makes engineering, repeat. This is called iteration. Again, imagine if Apple would have stopped at the original iPhone and said, this device is perfect, we don't need to improve upon it. So you want to repeat steps 1 through 4 until you're happy. And really, you'll never be happy with the design. So you repeat steps 1 through 4 until you run out of time, is usually what happens. And that's usually what happens in the real world as well. Okay, that was the engineering design process. I do want to see that shining through in your engineering notebooks for this robot. And that concludes the strategic design unit notes.